Composition of functions. I'm going to first relate this back into function notation. So if you recall, function notation is where you replace the y with an f of x. And here's my rule. It's 2x plus 1. So really it means I'm going to multiply whatever x value by 2, and then I'm going to add 1 to it. So with function notation, if I replace the x with a number like, say, 3, that means that in my rule, I'd replace the x with that number 3. And, multiply, add, and get 7. So f of 3 is 7. Well, with composition of function, instead of replacing x with a number, I'm going to replace it with another function. So f, and then inside of that would be a g. I'll go back to the domain thing here in a little bit. But here's how it works. I look at the outside function. That's the function I'm dealing with, function f. So in my two functions, I got function f here, and I've got function g. Okay. I'm going to start off with function f of x is equal to 2x plus 1. And I'm going to take the x out and put function g on the inside of that. So I'll take this x out, and I'll replace it with what was function g. So I'll have to multiply that by 2, and then I'll add 1 to that. Okay. If you remember systems of equations, this is a lot like substitution. The only thing is I'm not working my way to getting x equals, say, 5. I'm going to come up with a new function. So 2 times 4, 8, minus 10x plus 1. Got a couple like terms, so I can go 9 minus 10x. Okay, so that's what f of g of x. And that's how you would read it. F of g of x. So now if I flip around and I go g of f of x, now I'm going to start with g of x. I'm going to take the x out and replace it with f of x. And in this case, the rule was 2x plus 1. I'm still going to keep the 5, the multiplying by 5, and the 4. So I'll distribute 10x, a negative 10x minus 5. And then I've got that 4. Again, got a couple like terms, so minus 1 minus 10x. There you go. That's g of x. Notice that if I change the order, so if I put an f on the outside, this is what it simplifies to. If I put g on the outside, this is what it simplifies to. So the order does kind of matter. Yeah, we'll work through a couple more here. Oh, by the way, I talked about domain. So domain in this case is all real numbers because there's no number that I can't multiply by 10 and do all that adding and subtracting to it. Okay. The domain of this guy too is also all real numbers because there's no problems with multiplying by negative 10 and subtracting a 1 or adding a negative 1. Okay, really domain only backfires on me is if I'm dividing by 0 or taking the even root of a negative number. Okay, so here's some new functions of f and g. So here's how I'll kind of break it down again. I'm always going to look to the outside function, and it's f. So I'll go f of x equals 2x to the negative first. I'm going to take this x out, and I'm going to replace it with g. So g is the x squared minus 1. So I'll go to x squared minus 1, and I'm going to raise that to the negative first power. Okay, now I'll simplify as much as I can. Exponent first. So that means that everything in parentheses is going to go down to the denominator. Remember, if you're, a negative attitude in the upstairs of the house, I'm going to kick you to the downstairs of the house. So 2 over x squared minus 1. Okay. Now if I flip it around and go g, so again, I'm going to look to the outside, go with g. Function g of x is x squared minus 1. So now I'll take the x out and replace it with f of x, which is 2x to the negative first. Okay, and I'm still going to square, and then I'll subtract 1 to that. So 2 squared is 4. X to the negative 2 minus 1. Again, do my exponent rules to that. Here I've got this negative exponent. Negative 2 is, again, being negative in the numerator, so it's got to go downstairs. So 4 over x squared minus 1. Okay, so different. F of x and g of x are totally different. Okay, now the last one, I'm going to put f back inside of itself. So again, I'll start with f of x. Then I'll put another f of x in there. So kind of within itself. Okay, so 2 to the negative first. X to the, well, negative 1 times negative 1 is positive 1. So that's not going to move anywhere. Okay, I could bring that downstairs. So I got 2x over 2. Reduce that out, and I just get left with x. Now, I'll go backwards on my domain ones. I'm going to start with this last one here first. X is just all real numbers. There's no problem right there. It's this middle one where I'm dividing. So now x is all real numbers except x can't be 0 because I can't have a 0 in the denominator. Okay, and this one's a little trickier. So now x would be all real numbers again, except if I look at this denominator and solve this equation right here, I'm finding out that there are two numbers, a positive and negative 1, that x can't be. Okay, because I cannot divide by 0. Okay. And there you go. That's kind of a composition of functions.